Hello, my name is Sakina Patanwala and I will be presenting our final project named Prediction of Antibiotic Resistance and Length of Stay for ICU Patients. For this project, we have worked under the guidance of Providence Healthcare. Machine learning has been revolutionary when it comes to the banking and education system, and now it is time to implement it in healthcare in order to potentially bring social benefits to the public. Hence, we decided on exploring and hopefully contributing towards something beneficial to the healthcare system that we, as future data scientists, can implement and improvise. Antibiotic resistance imposes a heavy burden on healthcare because clinicians rely on prior experience and static guidelines to prescribe antibiotics without accounting for patient-specific attributes, which has led to several fatalities. This is why the first goal of our project is to predict the resistance an organism opposes towards different antibiotics. Likewise, it is extremely insightful for medical professionals to have an estimate of how long a patient is likely to stay in the hospital and if they have a high chance of being in danger, which has led to our second goal of predicting a patient's length of stay and mortality rate using their demographics and first 24-hour vital signs. We worked with the openly available Mimic3 dataset. In order to handle and process over 40 gigabytes of data across 40 tables more effectively, we utilized various data science tools including DataPrep and BigQuery. Also, to reduce any chances on errors due to possible lack of healthcare domain knowledge, we consulted with medical professionals for feature selection and referred to previous researches. Feature selection was made differently for both objectives. We conducted cross-validation for our first goal and used chi-square and ANOVA for feature selection for the second goal. SMOTE was used for balancing classes for our second goal. Next, we conducted hyperparameter optimization and then analyzed the results for selecting the best performing model for each of our goals. Lastly, we used Docker to containerize and serve our data product on any machine. We designed our data product with two main goals. First, to have it perform as a general dashboard with processed and saved data, and the other for delivering real-time prediction. We also deployed both applications on production using Docker and registered the Docker registry images on a Github registry space to facilitate the release of products. At the same time, we utilized AWS EC2 to hold the Docker containers for enhanced availability. Here is a live demo of predicting the resistance of an antibiotic. A caregiver can enter patient-specific details to determine if the organism is resistant or sensitive towards the antibiotic name entered. Now we will be seeing the predicted results for a patient searched by ICU Stay ID. When the probability is below 50%, the gauge bar has a blue color. When the probability is above or equal to 50%, the gauge bar will turn red and alert the caregiver. So here is the end of our presentation, and we look forward to seeing how we will be implementing it with Providence Healthcare in the future. If you have any questions or would like to reach out to any of us, here are our contact details. Thank you.